Looking at parallel lines, okay, two parallel lines, they never cross each other were you to extend them beyond. You often show this using little arrowheads on the diagram, and that shows that two lines are parallel. And if you were to write that you wanted to say that L and M were parallel to each other, we would use this notation here where you have two vertical lines. This means L is parallel to M. If we were to draw a line that went across them both, so if we draw a line like that, for example, this is called a transversal. Okay, and a transversal has now created 8 angles, 1, 2, 3, 4, 5, 6, 7, 8. And there are certain rules to do with these 8 angles and the relationship between them. The first rule is alternate angles. And alternate angles are where you have two angles inside the two parallel lines that are one either side of the transversal. And it creates a sort of a Z shape. If you look at the two angles and the two parallel lines and the transversal, you can make a Z where the two angles that we're looking at are effectively inside the Z. Second example here, the Z's a bit stretched out, okay, and it's back to front, but the key point is inside the Z angles, the napes of the elbows, okay, are these two angles. Okay, and they are the same. They are equal in size. They are the same measure in terms of degrees. The second rule is what's called corresponding angles, and corresponding angles you'd find them on the same side of the transversal and in a sense both above the parallel lines or both below, and it creates an F shape. So you can see there's a sort of an F there where inside the angles of the F you've got two angles, and they are the same. They are equal in measure. They're the same size in terms of degrees. It doesn't matter which way you have your F. Oops, sorry, excuse me, hang on a second. Is that wrong? The F there, or indeed the F. That's the standard F there, I suppose. Okay, all the others are upside down or back to front. But the key idea is you're noticing that you've got two angles that are on the same side of the transversal, and you can see it's above the parallel line and above the parallel line. Another useful rule is about interior angles, or sometimes called co-interior angles. And the key idea is if you have two angles inside two parallel lines on one side of the transversal, I've drawn a C shape there, okay, and you see they're sort of interior to that little area. Okay, these two angles sum to 180 degrees. So let's say, for the sake of argument, we know that this is 110. All I have to do is, therefore, if I know that piece of information, all I would have to do is subtract it from 180 to find the other angle, in which case it would be 70. So looking at this diagram, if we knew that this angle here was 60 degrees, if we were told that piece of information, then I can actually find out about all the other angles that are there. So you can see clearly marked the alternate angle, okay? So that angle there is 60 degrees. Why? Because it's an alternate angle. But we can also work out some other angles. So for example, this angle down here, because it corresponds to the angle that was 60 degrees, we also know that that angle is 60 degrees. That's corresponding angles. We can also appreciate several other rules you've already learned about vertically opposite angles. So I could have worked out this 60 by just knowing it was vertically opposite this other 60. We also shouldn't forget that with a straight line, you have angles adding up to 180 degrees. So you can see here, this angle here, 60 degrees. Next to it is another angle. Okay, and if I take 60 away from 180 degrees, I end up with 120. So we can slowly work our way around the diagram. I'll go through some more examples. This will be a bit clearer because the angles are actually labeled A, B, C, D. And we'll also look at the two angles that we haven't actually dealt with. Okay, so there's another one here and another one here. We'll call them E and F when we get to them. So looking at these angles, let's start off. And by the way, it doesn't matter what order you do these angles in. I don't have to do it in alphabetical order. But let's start with A anyway, just to go through the first one. So A, what is the size of angle A? Well, we see that it is vertically opposite the 115 degrees that we have been given. Okay, so A is also going to be 115 degrees. And we should always, and when you do your homework, I would expect you to also write next to it the rule that it relates to. Okay, so A is 115 degrees. Why? Because it's vertically opposite to the angle that we knew. Let's look at D. As I said, you don't have to do it in alphabetical order. Let's look at D next. Okay, so D, what can we say about D? Well, if we notice that D, if we see that straight line there, we can see that D and 115 make a straight line. So therefore, we know that D is going to be 180 minus the 115 degrees that we're given, in which case my angle is going to be 65. Why have I done this? Because it's a straight line. So I write my rule next to it. Moving on, let's look at B and C. Well, we can find out B if we actually try and look at what it has in relation to the other angles. So I could go with the alternate angles. So if you see here, if I draw in a Z shape there, you can hopefully very clearly see that B and 115 relate to each other. Okay, so B is alternate. It's 115 degrees. You can see the angle is on opposite sides of this transversal inside parallel lines. And lastly, C, there's a number of different ways I could work out C. Now, firstly, I could say that C is vertically opposite to B, but I could also use the idea that if I appreciate an F shape, C and 115 degrees sort of correspond, as we say. So it's their corresponding angles. So each time I'm working out my answer, it's either I know the answer because it's the same, or I might have to subtract it from 180 degrees. And I'm always writing next to it the rule that it relates to. So when you're doing your homework, I would expect to see the same sort of workings. Okay, the angle letter, the size of it, and the rule next to it. If there's a calculation to be done, I expect to see that calculation. And this is the sort of process I'll expect to see from you for question 2, 5, 6, beyond 7, 8, 9, 11, and 12. Question 1, 3, 4, and 10, I think they're slightly different. They're not asking you to actually calculate any angles. All they're asking you to do is make connections using the rules that I've just gone through and identify the angles. If you read the question very clearly, it tells you what you're supposed to actually identify. So in this instance, the shaded angle is the one that's in yellow, and which one is corresponding? Well, in this, for the very first one, 5 is the corresponding angle because it is on the same side of the transversal above the parallel lines, making that F shape. So you simply answer the question by saying 5. What you're doing is you're pairing up or identifying angles that relate to a specific rule as asked. You have this until Friday to get this work done. I'll be expecting a hand in of your work so I can see how you're getting on. And in particular, I will repeat, you need to show your working, you need to show the rules that are used for each of the angles, just as I gave you that example there. I expect to see that sort of working.